Okay, so let's talk about the substitution method. So when it comes to the substitution method, the whole point is to take one of your equations and substitute it into the other one. Now the way that we do that is that we hope that either one of our equations is already solved for a variable, like we do here. So here we got a lucky situation here. One of our equations is already solved for one of our variables. X equals 5y. That's great. If we don't have this situation here, what we would want to do is we would want to take one of our variables and get it solved. So take a look at one of the other videos just in case you need to practice that situation more. But for this one here, one of our equations is already solved for one of our variables. It doesn't matter which one, as long as one of them is solved for x, one of them is solved for y. Either one is perfectly fine. So for this particular problem, the second equation is solved for x. And the whole point of substitution method is to take one equation and substitute it into the other one. So the way that that's going to look like here, if x is equal to 5y, so x equals 5y, 5y equals x, they're interchangeable. All right, so what I'm going to be able to do then, so if x equals 5y, that means I can take this 5y and plug it into x to the other equation. So what that's going to look like is this. So if I'm going to use the top equation here, right? So the bottom equation is solved for x. So I'm going to take this one and plug it into the other one. So I'm going to take the top equation, and the top equation is going to stay the same. The only different thing is that instead of x, I'm plugging in a 5y. So that's going to look like, well, 5x. But instead of x, we have 5y. Minus 25y is equal to 5. Okay, so plug one or substitute one equation into the other and solve. So if we solve this one, we need a little simplifying to do here. 5 times 5y, that's 25y. Drop everything else down. Still simplifying here, combining our like terms, 25y minus 25y. Well, that gives us a 0. And we're left with 0 is equal to 5. Now, does 0 equal 5? No, right? 0 does not equal 5. And honestly, if I were solving this problem at this point here, I would probably be going back up and trying to figure out maybe did I do something wrong, because this is a kind of weird answer. When it comes to solving systems, you're either supposed to have one solution, your lines intersect at one point, but you can have a no solution where your lines are parallel and they never cross, or you can have infinitely many solutions where they're the exact same line and they cross at every point. So we could have funny answers when it comes to these here. Our special cases over here, those are our weird looking answers. So we need to figure out, well, which case is this? We obviously aren't getting a point here because I didn't get like x equals 2 or y equals 5 or something like that. I got 0 equals 5. Now 0 does not equal 5. It will never equal 5. So when you're left with a situation like this where you get an answer that just does not make any sense, doesn't necessarily mean that you did something wrong. I would go back up and check just to be sure. But know that you can have funny looking answers when it comes to these. Just understand what they mean. So when you get something like this that does not make sense, this is a no solution. 0 does not equal 5. It will never equal 5. Therefore, this system here is messed up. We can't solve it. There's something going on with it here. No solution. We cannot solve it here. That just means that they are parallel to each other. They will never intersect. They have absolutely nothing in common.